Okay, guys, we're here for chapter 7.5, and today what we're going to be looking at are the two worked examples. Now, I can't remember if I've edited these from the worked examples just to make them a little bit different, but either way, I'm just going to go through these two questions here. To start with, we've got the first question. Calculate the interest rate per annum. So straight away, we can highlight that. That is what we're trying to find, the interest rate per annum required that would enable an investment of 4,500. So that would be your principal. So what I'm going to start by doing, and I know I'm kind of jumping in and around, is I've got my formula here, and as I read some information, I'm going to substitute it. So the 4,500 is going to be our principal. It has to grow to 5,200. Now, that's not $5,200 interest. That's the total amount of money at the end. That is our A value. Okay, so that's going to be the 5,200 over 3 years if the interest is compounded every 3 months. Now, as I said earlier, we're trying to find the interest rate per annum. That is this little I value in here. Now, what that means is we have to find out what the N value is. Now, a lot of people would just put 3 here, but that's actually incorrect. It's over 3 years, however, it's compounded every 3 months. If it compounds every 3 months, it compounds 4 times a year. 4 times 3 is actually 12. Now, what we're going to do is we only have one unknown here, and we have to think to ourselves, can we rearrange and solve this with the kind of level of math that we've been using? The answer is yes, albeit using some skills that many of you may not have used since grade 9. So what I'm going to do is copy it, and I'm going to show you how to rearrange it. Now here, I can't move this 1 in here because it's in the brackets, okay, reverse BOMDAS, I have to move the 4,500 first. Now, it's 4,500 times. What I'm going to do, hopefully this works, yep, I'm going to turn it into a divide, and that gets rid of it. Oops, that gets rid of the 4,500 there. Now, this is what we're left with. Now, to get rid of the 12, the opposite of putting something to the power of 12 is obviously 12th rooting it. For those who don't know their index laws, though, what I'm going to do, I'll just put a bracket around this so you can see. What we're going to do is actually put this to the power of 1 over 12. That's the same thing as finding the 12th root of that fraction. What that does is it gets rid of our little power there, and I'll just delete these and this and this, and we're left with just 1 plus I. From there, we can move the plus 1 round to the other side. I'm just going to copy and paste it again. So we get I. There we go. That's how I've rearranged that. Now what I'm going to do is just quickly enter that into my calculator, see what answer we get. Subtracting 1, we end up with an I value. If I can quickly rejig this a little, there we go, and I'm just going to round this, 0.01212. I'll just round it to there for now, because then it goes 13105. I'll just leave it there for now. A lot of students, here we go, give your, where is it? Calculate the interest rate per annum. Now, if you were to go, okay, is timesing by 100, you get 1.212% per annum. That would be incorrect. If you're watching the video at this point, I want you to pause it and think about why that would be incorrect. All right, so now I'm going to go through the answer for why this is incorrect. So in this case, as we established earlier by using the value of 12 here, this is the interest rate per quarter or per 3 months. If we want to find the interest rate per annum, I'm just going to copy this down again. The interest rate per annum, what we have to do is multiply that by a total of 4. And then what we have to do is times it by 100, and that gives us the percentage rate, just like I did from here to here. So 0.01212 times 4 times 100, we get a percentage rate, 4.848. So therefore, the rate is 4.484% per annum for the investment. All right, that's how we work out the rate. We rearrange and find for I. Now let's go to our next question. Calculate the length of time required for $700 to grow to $11,000 at 7.7% per annum, compounded every 6 months. So just like I did beforehand, I've got my formula. Let's substitute what we know. It wants to grow to 11,000, not 10,000. All right, so there's 11,000. We know that we start with a measly sum of 700, so we already kind of assume, because it's going over 10 times the amount, we know it's going to be a while. Do we know the interest rate? We do indeed. It's 7.7% per annum. Now, again, if you just said, oh, that's 0.077, you would be incorrect. What we have to do is take our 0.077 and divide it by 2 to get 0.0385. Now, what that tells us is the rate per every 6 months. Now, here, it's the end value that we're trying to find. So, from here, using the mathematics that we know, there's actually not an easy way to go about solving this with maths algebraically. We have to do a substitution method or guess and check. And the reason is, to actually solve this, you would need logarithms, and in general maths, we don't use logarithms. So let's just start with n equals 10, okay? And let's find out what happens. So instead of putting 11,000, remember we want it to grow to 11,000. So 700 times 1 plus 0.0385, and that's all to the power of 10. I only ended up with $1,021. So that is definitely not going to be big enough. I'll still put it in, 1,021. I know this might seem a bit crazy. Let's go 50. Actually, no, let's start with 30. Let's see where 30 gets us. Okay, now when I enter 30, again, still not really helping us in this circumstance. We get 2,174 rounded, okay? So that's still, in this circumstance, definitely not good enough. Let's try again. This time, let's make it 60. For argument's sake. All right. At 60, so doubling, we end up with $6,753 rounded up. So we're getting closer, but definitely not close enough. Let's try 80. Okay, now when I've substituted 80 into my calculator, I end up with $14,375. So now we've gone far too big. Let's see if we can try, well, we definitely can. Let's try 70 and see where we end up. Now, I'm not going to start writing these. I'm just going to tell you what the numbers are. When I entered 70, I got $9,852. Let's try 75. 11,901. Now we're getting close to it. Now it has to grow to 11%, so we want to find the two numbers that it's between. I'll try 73. I got $11,035. So 73 is our maximum. Let's see what it is at 72 just to be safe. 10,625. So therefore the answer, it would take 73 compounding periods. I'll just put that working here. So when I use 73 as a compounding period, I get $11,035. Now, how long did that take us? Well, it took us 73 periods. Notice I said 73 periods there. If you were to type the following, that would be incorrect. And the reason that would be incorrect is, remember that this n value that we originally had is the total number of compounding periods. Reading this question, just like we changed the rate to 0.0385, this compounding every 6 months affects our n value. What we have to do is take that 73 divided by 2, and what we would get is 36 years and 6 months. So 36.5, 0.5 of a year is 6 months. So yeah, that's how long it takes for that $700 to grow all the way up to that total of $11,035. Now, if you tried to guess and check, say like 72.8, 70, we can't really do that because remember, the interest only grows when it compounds. And that's everything for this video, guys. Hopefully this example made sense for you. Thank you.